Hi everyone, we are going to learn calculus and Laplace transforms. The first topic is method of Lagrangian multipliers. And here, suppose we want to find the maximum and minimum values of f of x, y, z. F is having three functions where x, y and z are subject to constraint equation. Let us take it as g of x, y, z equal to 0. So we define the function capital F of x, y, z equal to small f of x, y, z plus lambda into g of x, y, z. So here this lambda we call it as Lagrangian multipliers, which is independent of x, y and z. So the necessary conditions for maxima or minima are dou f by dou x equal to 0, dou f by dou y equal to 0, dou f by dou z equal to 0. And solving the four equations for four unknowns lambda, x, y and z, we get the result of maxima and minimum value. So this method is applicable for more than one constraint equation connecting the variables. So let us see a problem. A rectangular box open at the top is to have a volume of 32 cc. Define the dimensions of the box that requires the least material for its construction. So here they have taken a rectangular box which has 6 sides and which is open at the top. So one side is open, we should not consider. So we have now only 5 sides and its volume was given 32 cubic centimeter. So let us take x, y and z be the length, breadth, height of the box. F of x, y, z we have to find out. So here look at the question. Find the dimensions of the box. We want to find out the dimensions that requires the least material for its construction. So when we are talking about the least material for construction, we have to take surface area of the rectangular box. So what is the surface area of a normal rectangular box? We have to write 2xy plus 2xz plus 2yz. But here in our box on the top, one side is open. So we have taken only 5 sides. So let us write f of x, y, z equal to xy plus 2xz plus 2yz. It seems that one xy side is on the top. So this is the surface area formula for our rectangular box. Just take it as f of x, y, z. Now the given constraint equation is volume of the box is 32 cubic centimeter. So what is the volume of the rectangular box? X, y, z equal to 32. Let us bring 32 in front. In the opposite side, x, y, z minus 32 equal to 0. So let us take the constraint condition as g of x, y, z. Now we have f and we have g. So let us define a function capital F of x, y, z. That is equal to f of x, y, z plus lambda into g of x, y, z. Now write the values. F is xy plus 2xz plus 2yz plus lambda into g is xyz minus 32, where lambda is a Lagrangian multiplier. We should find out the maxima and minimum value. Before finding that, we need to find the stationary points. So let us take the necessary condition to find stationary points. Fx must be equal to 0, fy equal to 0, fz equal to 0. For that we need 3 derivatives. So fx, it is nothing but dou f by dou x. So differentiate this equation with respect to x. So when I differentiate x, x's differentiation is 1, y is constant. Here x differentiation is 1, 2 is z. And here there is no x, it becomes 0. Then here on differentiating, constant term differentiation is 0. X, y, z, x differentiation is 1. We get lambda into y, z. So I have differentiated with respect to x. I got y plus 2z plus lambda into yz. Next, we differentiate with respect to y. So when I differentiate with y, x is constant, y differentiation is 1. So I write x. Here there is no y, it becomes 0. Then here 2yz, when I differentiate y, it becomes 1. So I have written 2z. And here when I differentiate y, I will get lambda into x into z. And constant term differentiation is 0. So we get this x plus 2az plus lambda into xz. Then differentiate with respect to z. So we get, here there is no z, becomes 0. And here when I differentiate z, I will get 2x. Here differentiating z becomes 1, I will get 2y. Here differentiating with the z, I will get only xy multiplied with lambda, lambda into yx. And a constant differentiation is 0. So we got 3 equations. Now solving all 4 equations. To find the stationary point, we write fx equal to 0, fy equal to 0, fz equal to 0. Now what is fx equal to 0? Already we got the equation y plus 2z plus lambda into yz equal to 0. Now bring this lambda into yz to the opposite side. I am getting y plus 2z equal to minus lambda into yz. Then multiply this equation throughout with respect to x. So I get this equation. Let us take it as for 1. Now take fy equal to 0, x plus 2z plus lambda into xy. Take it to the opposite side. Then multiply with y. We get xy plus 2yz equal to minus lambda yxz. Let us take it as second equation. Fz equal to 0. Now 2x plus 2y plus lambda into yx is equal to 0. Let us take lambda into yz to the opposite side. We get 2x plus 2y equal to minus lambda into yx. So multiply throughout by z. So we get 2zx plus 2zy is equal to minus lambda zyx. Let us take this equation as 3. Now we want to solve all 3 equations. The first equation, second equation and third equation we are comparing. Now I can compare first equation with second equation. Now let us take for 1 and 2. We get xy and xy will cancel. We are getting 2xz is equal to 2zy. Cancel 2 and cancel z. And from this equation I am getting x is equal to y. And we take the first equation with last equation, third equation. So first equation and third equation is comparable and cancel this 2xz and 2xz. We get xy equal to 2yz. Then we get x is equal to minus 2z. It is x is equal to minus 2z. So now we get x is equal to 2z. Here this is equal to x equal to 2z. So from these two equations I am getting x is equal to y and x equal to 2z. Now I am getting x is equal to y equal to 2z. Now substituting these values in the constraint condition. What is the condition given in our problem? X, y, z equal to 32. Substitute x value as 2z, y value as 2z equal to 32. Now I am getting 4z cube equal to 32. Z cube equal to, bring 4 down, we get 8. So z equal to 2. After finding z value as 2, substitute in this equation. What is your x? 2 into 2 which is 4. Then y equal to 2 into 2, 4. Now what is x, y, z? Already we have assumed x, y, z are the dimensions of the rectangular box. So we got our x value, y value and z value. So the dimensions are 4 centimeter, 4 centimeter and 2 centimeter. So this is a wonderful example we have seen under Lagrangian multipliers. Thank you, students.